How are all JavaScript numbers floating point? Have you ever wondered why all numbers in JavaScript are treated the same way? Let's break it down and understand how this works. In JavaScript, every number you use is stored as a floating point value. This follows a standard known as IEEE 754, which is used widely in programming. What does this mean for you? It means there is only one type of number in JavaScript. Whether you are working with whole numbers or decimal numbers, they are all treated as 64-bit floating point values. This single numeric type simplifies things but also comes with some quirks. The way these numbers are structured is quite interesting. There is one bit to indicate if the number is positive or negative. Then, there are 11 bits for the exponent, which helps scale the number. Finally, there are 52 bits for the fraction or mantissa, which holds the significant digits. This setup allows JavaScript to representing a wide range of values, both very large and very small. Now, let's talk about some important behaviors that come with this design. First, when it comes to integers, JavaScript can accurately representing them only up to 15 digits. If you go beyond that, you might run into precision errors. This is because the floating point format cannot exactly representing all integers larger than to raise to the power of 53 minus 1, which is about 9 quadrillion. Next, there are decimal precision issues. Since floating point numbers are based on binary, some decimal fractions cannot be represented exactly. This can lead to small rounding errors during calculations. For instance, if you try to add to decimal numbers, you might not get the exact result you expect. JavaScript also supports scientific notation. You can write numbers in exponential form, like 1.23 times 10 to the power of 5. This is a natural fit for floating point representation and can be very useful in your code. From a web development perspective, knowing that all JavaScript numbers are floating point is important for handling numeric data correctly. For example, if you are working on financial calculations or need precise decimal values, you might need to use some strategies to avoid issues. One common approach is to round results carefully using methods like to fixed or to precision. Another method is to perform calculations in integer units, such as cents instead of dollars, to avoid floating point rounding errors. Additionally, there are specialized libraries available for arbitrary precision arithmetic if you need exact decimal representation. Understanding that JavaScript uses a single floating point number type makes it easier to work with numbers in your code. However, it is essential to be aware of the characteristics and limitations of floating point arithmetic to write effective web applications.